I'd like to venture beyond the theoretical discussion of clip envelopes from the previous video with a practical example. To do so, I'm going to attempt to recreate the same basic filter cutoff effect by utilizing a clip envelope. I'll start by opening the Envelopes box by clicking on this E button. The Clip View area expands to show all of the available options and parameters for working with clip envelopes. It's important to note an important change in Live 9 with respect to how this editing area works. In previous versions of Live, clicking on this E would open up the Envelopes box and clip envelopes were instantly available for editing. Clicking on this E will still open up the Envelopes box, but now the editing area defaults to Clip Automation. This is a new feature found only in Live 9. Clip envelopes are now accessed by selecting the appropriate parameter automation option in the control chooser, and then right-clicking in the clip view and selecting Show Modulation. The parameter will now show in the control chooser dropdown. The word modulation will be added just so it can be distinguished from clip automation for the same parameter. By the way, you'll notice I keep throwing the words modulate or modulations around. A modulation is simply a change that continually cycles between a high value and a low value. After selecting the frequency parameter for modulation, the clip view will display a horizontal red line in the middle of the waveform. This visually represents the audio clip. If I create a breakpoint at the start and drag it all the way down, and another at the end and drag it all the way up, it would appear, at least visually, as if I have created the ascending sweep I was looking for. But take note of a very small but very important detail. The breakpoint values are not shown as frequency values as they would if it were an automation line. Rather, the display indicates percentages. Why? Because clip envelopes do not change the specific value of the frequency parameter. Rather, it modulates the parameter value up or down using the parameter value I've chosen as a starting point. Allow me to break that down further. I'll head back to the auto filter device and change the frequency value to around 500 Hz. Now I will double-click on the clip and look at the clip envelope again. Remember that line I started with in the center before we added breakpoints? That line represents a 0% change in the parameter value. So if I delete these breakpoints and return the line to its starting point in the middle, there would be no change in the frequency and it would stay at 500 Hz. Now if I add the breakpoints back and raise the N1 to its highest level, you'll see that the value shown is 50%, meaning the ramp will increase the frequency value by 50% of the total frequency range. Similarly, if I take that breakpoint and move it below the line to its lowest possible value, it will show a value of negative 50%. This means the frequency value will start at 500 Hz and drop 50% of the total frequency range. At first, this might seem confusing, but it's actually a very powerful tool because I now have the ability to program a parameter change while still being able to alter the parameter's base value. Look at the auto filter again. This time, I'm going to change the frequency value to its maximum value of 19.9 kHz. Returning to the clip envelope view, I will restore that second breakpoint to a positive 50% value. Now I'll play the clip. Nothing happens to the frequency. Why? Because the clip envelope starts at a 0% change, which represents 19.9 kHz, and moves up 50%. But 19.9 kHz is the maximum value, so it can't move up 50%, or even 5% for that matter. But if I push that breakpoint back down to negative 50%, I will hear the clip start at 0% change, again 19.9 kHz, and move down 50% appropriately. The filter doesn't close completely. It'll stop halfway between the entire range of values, so halfway between 19.9 kHz and 26 Hz. If I reset my breakpoints to their original locations, I now have a program filter sweep, but I can continually change where the sweep begins and ends by editing the center value. I'm not locked into anything. I can spontaneously adjust the center point and therefore the range of the frequency sweep at will. It's this feature that can allow for increased creative freedom over traditional automation.